For one of the labs, you're going to be measuring out or massing out 1 gram of sucrose, always make sure that you're using weighing paper, zero out your balance, and then gently tap out 1 gram. When you get close, it gets a bit more difficult, but don't go overboard. There's 1 gram. Carefully take that 1 gram off so you don't lose any of the mass and set it aside. Then, using a new weighing paper, zeroing it out once again, you want a ½ gram of yeast. Same rules apply. Until you get to 0.5 grams. Those two substances will now be put into your flask. Setting up the capstone probe itself is actually pretty simple. Each one will have a USB that will go into your selected computer. I'm using the teacher station, so you're not going to be able to see me put this in, but you'll be using the laptops that are provided in the lab. After that, take whatever sensor you're using, in this case the carbon dioxide sensor, gently push the two together to link them, and that's it. This will be going into whatever you're going to be testing. For instance, in this we have sucrose and yeast, and we'll be putting water in. Gently put the probe in, making sure that you're not getting it wet, and it may help to actually lock this into a ring stand. That way you don't have to sit there and hold it the entire time. Now for hooking the probe up. You're going to use that USB to plug into whatever computer you are using, and then launch Capstone. Go to Sensor Data, and it should populate with whatever probe you're using. In this instance, we are using the carbon dioxide concentration probe. It sets up the graph for you with your Y and X axes, and then you're going to be able to add a title after you record your data. Come to the bottom, scroll to 2 seconds, and you're ready to start your data collection. Several times throughout your lab, you will notice the bolded terms dump, cap, start. You're going to dump your 37° centigrade water into your sugar and yeast mixture. Give it a slight swirl. That's the dump. Then you're going to cap. And at the same time, your lab partner, or if you're very dexterous, can hit record on the screen. You'll notice the bottom of the probe has a flashing light. That indicates that it is measuring data. So you're going to dump the water into your yeast and sugar mixture, immediately insert the probe and seal it off well, and then hit record. Record will start to generate the data on your screen, and you'll see a line starting to build. Now, off screen, I'm going to go through that procedure of dump, cap, and start. It's very difficult to do alone, so there goes the water in, as you can hear. I'm going to cap it with the sensor. The sensor is in, and it's being held down. And we're going to hit record or start. Data is now being generated by the amount of carbon dioxide that is being produced by the yeast. Your axes should self-adjust for some time, and I would recommend recording data for about 20 minutes. You'll notice that the clock in the lower left is recording the time for you. And you can see the CO2 continues to go up and increase, and the graph continues to collapse, so you can see all of your data at the same time. It's important that you keep the stopper firmly in place so no CO2 escapes. The CO2 that's being produced is the same CO2 that is responsible for the small holes in freshly made bread. It's also the same product, the CO2, that is used to carbonate beverages. And we continue to generate a large amount of data. I'm not going to go for 20 minutes. I want to make this video brief and informative, not a full data collection. When you're ready to stop, simply hit stop. Data is only as good and useful as the explanation of what data actually has been generated. Fortunately, Capstone allows us to skirt around some of the older ways of doing certain things. For instance, you have this number of data points recorded every 2 seconds, and at any one point you can click on it and tell what's happening. However, scientists tend to look at general trends. So what we would really be concerned about here is the slope of the line. We used to have to go point to point, measure it out, and use the old slope formula of y equals mx plus b. However, if you come to this tool at the very top, I say it looks like surgical stitches almost, with a scar in the middle and the points where the needle was put through off to the side. Go to the drop-down menu. You have several different options. For our purposes, we're going to hit linear slope. By clicking off of that, you'll see this box seems to be in the way. Drop it down, and now you have the slope of the line. We still have our x-axis of time. We have our y-axis of concentration in parts per million of carbon dioxide. But all good graphs also need a title. Come down to the bottom, double-click if there's a field populated, and tell exactly what your graph shows. In this instance, carbon dioxide in parts per million produced by sucrose solution and baker's yeast over or versus time in seconds. Your title shows a few things. It shows pretty much everything you did. It's showing what you produced, carbon dioxide in parts per million, how you produced it using sucrose solution, we'll make that correction, and baker's yeast, and time. Where did the water come in here? It comes in at our sucrose solution. Being a solution obviously means it is in a liquid form. So now you have everything you need as far as your graph is concerned. You can come to File. Make sure it's on the screen for you here. Drop down to Print Page Setup. Make sure that you're on Letter. Make sure you are on Landscape. Hit OK. Unfortunately, for some reason, when you finally go to print, it typically moves it back to Portrait. So you want to drop down to Landscape once again. If you're in room 116, the lab, you want to make sure that your print queue is on 2-116 HP. You don't need to be worried about color. And then you'll hit Print. Almost immediately it will disappear. And it's pretty straightforward. Now this data will be in your screen for future runs. In the coming weeks, you'll be stacking data, more or less, from 4 different runs in there, and we'll have multiple lines. That's pretty much all the steps to actually producing your graph. So now, when you take a quick walk back to the printer, this is what you'll end up with. This is the actual product that you'll be turning in to your instructor. Of course, you'll want to put your name on the bottom so that I know who to give credit to. Once you've printed your data for submission, you'll want to close out of the program. Go to the X, of course, in the upper right-hand corner, and close. It will prompt you to ask if the experiment has been modified. Do you want to save your changes? You can save them because in the future, you're going to be having several runs stacked up, as I already mentioned. Go ahead and save it as necessary in your files. I'm going to call this one CO2 production with sucrose. Thursday night lab. I'm saving it into my OneDrive. You could save it to a thumb drive if you wish. It will save it as a Pasco Capstone file with the file name of .cap and save. It will take it a moment, make sure you wait for the scroll, and then you're closed out. Because I'm working alone in the lab, I can't really show you the entire dump, cap, start procedure. So I have already taken the liberty of dumping. Now I'm going to cap with the probe, holding it tightly, and then start recording. Almost immediately you see that we start to get a CO2 production curve. We're going to normally go for about 20 minutes. However, I'm going to shorten the time frame that we're going to talk about here, just so you can see what we're talking about as far as putting the rest of the parameters on your graph. You'll notice there was a dip. That dip is there because I pushed a little bit too much on the stopper. That's why you have to be very consistent and lock it into a ring stand if you are able. You'll notice that the axes start to collapse a little bit more. At least the x-axis does as we collect more time and data. However, your y-axis, the CO2 concentration, does not. I'm going to stop the run because you can see that there is an obvious increase continuing. However, the yeast will eventually run out of sugar, runs out of food. And much like anything that's living, once its food source is depleted, it's going to stop its production. So I'm going to pull the probe and stop the recording. To stop it, the button right down here in the lower left, right next to the clock. That stops your run. Excuse me, I'm going to disconnect it. Then we're going to go in and do some graph modifications. The nice part about graphing on a computer is that we kind of dispense with some of the old calculation methods that we used to have to use when we did this by hand. The most important is probably right up here. There is a button that looks, I can only explain it as looking like a surgical scar with the needle points. You're going to click that down arrow. All of these formulae become available to you. The one we want is slope. We used to know it x2 minus x1 over y2 minus y1, or y equals mx plus b. We no longer have to do that. All we need to do is click. Click out of that drop down and you'll see a line up here. That is your slope line of your data. You can grab the window that it displays that and pull that down so that your data is visible. Then come down to the graph title. Any good graph needs to be represented by a title. Click that to highlight, and I'm going to type out what I consider a good graph name. Carbon dioxide production by yeast. Let's be good about it. Baking, the baker's yeast. Hopefully I didn't actually spell. Keep baker's yeast in sucrose, please not sugar, solution. By putting solution in there, it represents the water. Over or versus time in seconds. A couple of ways you can write that. You could put time and then just put seconds. And then we also have to come back here to carbon dioxide production. We don't have any units, so we have to go ppm, which is of course parts per million. So now we have a good title, carbon dioxide production in parts per million by baker yeast in sucrose solution over time. That's a great title. That's an acceptable title. Now, up to the upper left, to File, down to Print. Make sure you're on the correct printer for wherever you're printing. In this case, we're in the lab, 116. We want a landscape view. That will stretch the data much easier to see. And then we hit Print. Go back to the printer, pick up your paper. When you come forward again and put it into your report, make sure if you're putting a paper copy in that you have your name on your graph. And now there's our data on the computer, and what you'll notice is your graph matches exactly what is on the screen, and that, of course, once you put your name on, would be acceptable to turn in. This one is printed in black and white. If you can find a color printer somewhere, you could definitely put it in color, although that's not required. As you add more lines, add more data, sometimes it is better to actually have it printed out in different colors. However, we also have the legend up here, and you can graph things with different shapes. For instance, this one, the CO2 production at this temperature, for example, is small dots, blue dots on your screen. As you get into future labs, you're going to be recording several different things. You may be comparing data with the catalase as far as temperature, pH, concentration, and a number of other things. You'll have different lines. It will become very confusing if everything is little blue dots. So your legend up here will be changeable. You'll be able to put triangles, squares, stars, different colors as well. In the next lab, you're going to be comparing data from different concentrations over time of your enzyme. For instance, you're going to look at the effect of enzyme concentration on the rate of reaction, the effect of substrate concentration on the rate of reaction, the influence of temperature on the rate of reaction, and the influence of pH on the rate of reaction. Those are the main things that really kind of affect enzyme actions, as the name implies. Now, I've graphed, of course, the graph you just saw me do, and now I just put a little bit more, a few more runs in there. So what I wanted to show you is how to stack those runs so that all of your lines appear on the same page. Switching gears for one more thing. In the next lab, we're going to be looking at a lot of different components that can change what happens with an enzyme. For instance, we're going to look at the effect of enzyme concentration, the effect of substrate concentration, the effect of temperature concentration, and the effect of the influence of pH concentrations. Each of those is going to have 4 different treatments. For instance, if we're looking at the enzyme concentration, we're going to be looking at treatment volumes in milliliters of 10, 7.5, 5, and 2.5 concentrations. Substrate, similar. We're going to have increasing amounts of water. So what you want to be able to do is stack data. So you're going to be generating more and more data, and that's all going to appear that all you can do is delete it. It's going to be down here at the bottom. So for instance, I've run 3 different runs. I can look at each one of these, or I can just delete them all. Let's not delete any. Let's stack them all on top of each other. So to do that, you're going to come to your data summary and click on what I can only call the Google triangle, simultaneous viewing of multiple data sets. Click on that. That turns the button on. Click on the drop down and you can look at any one run. For instance, that's run 1 that is on the screen now. If I wanted to see run 2, if I want to see run 3, I can select all, I can select none. There's run 1, run 2, run 3, and I did not generate enough data for that one to be really pertinent. I'm going to go to select all. There's all your data. Now if you were to print this, you could see all the different data points that were generated, as well as their slopes, whatever you need to do. All the runs are over here on the right hand side, each represented a little bit differently. You can change the color of them if you wish, although let's just try and keep them a little bit the same. For instance, let's change run number 3, which is light purple right now. Let's make that, let's make it red, I guess. Okay, hit OK. And now we've changed that data set, and you can look at individual points in that. Lastly, and probably most importantly, is care of the probes. At the end, you're just going to disconnect by gently pulling them apart. Each one goes in its own separate bag. For instance, this is your CO2 probe, so it goes in the CO2 bag. Please make sure it goes in the appropriate bag. Maybe, there we go. Okay. As far as the actual USB link, that goes unplugged, and gently wrap the cord up, put it back in the appropriate bag. These probes are no longer made that I can tell. I believe they've been discontinued, but replacements for that probe alone that we've been using for this video, as best I can find, is about $150. So let's use them and take care of them so they last as long as we need.